All right, today we're going to talk about correlation and causality. So let's start by looking at a couple of new terms for us. A correlation exists. So let me kind of fill that in. Between two variables when higher values of one variable consistently go with higher values of another, or when higher values of one variable consistently go with lower values of another. In other words, if it looks like there's a relationship, as x gets bigger, y also gets bigger, or as x gets bigger, y gets smaller. Some sort of, and I use this with a lot of caution, predictability to it. Just because there is some sort of pattern does not mean that it's necessarily predictable. And one of the methods that we use to visually see a correlation is called a scatter plot. And it's a graph in which each point represents the values of two variables. Okay, so some examples of correlation. There is a correlation between the variables, let's see, height. That is, taller people tend to weigh more than shorter people. Again, generally speaking. So the taller one is, the more one weighs, assuming all other factors are considered the same. Let's see, the correlation between the variables, demand for apples and price of apples. Okay, another example of correlation that we can sort of see out in the real world. We're going to compare demand for apples versus the price of apples. Okay, so what that kind of means is as the demand increases for apples, there's sort of this relationship between price. So we would not be willing to pay $50 for an apple. But if they decrease the price enough, that would be an incentive for us to go out and get apples. So demand and price are sort of negatively related. Let's see, then there's correlation in piano players, so between practice time and skill. So those who put more time in learning the piano typically sound better and come out looking like they're just more talented, I guess. So let's take a look a little bit more deeper at these relationships. Let's give these relationships a name. So if there is no apparent relationship between variables, we say that there is no correlation. If both variables tend to increase or decrease together, so as x gets bigger, y gets bigger, or as x gets smaller, y gets smaller, we define that to be a positive correlation. As one variable increases while the other decreases, we refer to that as a negative. Sort of behave opposite each other. Okay, the more closely two variables follow the general trend, the stronger the correlation. In a perfect correlation, all data points lie on a straight line. This is the definition for the strength of a correlation. Okay, so here's sort of a graph that would be representing some things. If you look at the sides of the graph, we got weights, or specifically in carats, and we've got price in dollars. So it's safe to say we're looking at some sort of joule type data, where the more carats there are, typically the higher the cost. So as you kind of look at the graph, you kind of want to notice as x gets bigger, What do you also notice about the y values? They also tend to get bigger. And so there's this sort of this positively sloped line that we can draw in between the data values. So we would say that this has a positive correlation. And as far as strength goes, well, looking at the points, they look pretty closely grouped together. They look like they definitely are forming some sort of line. So we would definitely say this has a strong positive association amongst carrots and price. Okay, life expectancy and infant deaths. So just so we get a sense as to what we're looking at here, we're looking at countries where you're expected typically a person dies at a certain age. So over here in Kenya and Bangladesh, they're dying closer to a little before 60, whereas over in Mexico, they're dying. People tend to live a little bit longer, just 70. In Australia and Canada, people tend to live closer to 80. Okay, so that's what we're looking at the bottom. On the y-axis, we're looking at infant mortality. So these are the number of babies that are born that die per thousand. So again, just kind of picking a point here. Kenya looks like a person expected to die maybe about 57 years old, and they have about 50 deaths for every 1,000 live births. Bangladesh is another sort of extreme like Kenya. So Bangladesh, people might live to about 57-ish, but for every 1,000 live births, there's 100 infant deaths. Okay. Now, one thing to notice is that as X gets bigger, the Y's are decreasing. They're getting smaller on us. So it's kind of like if you draw a line in between, you'd have a negative slope. Okay. So this is what we would call a negative correlation. And the points are, again, they definitely look like they form a pattern. So we definitely would use terms like there's a strong negative correlation versus, say, a weak or no correlation at all. So we definitely would say this has got a strong negative correlation between the two values. Okay, so speaking of strength, just kind of point out that in both of these two graphs, as X is getting bigger, Y is also getting bigger. And so both of them would have a positive line that would associate X and Y. However, the first picture has a much stronger correlation versus the second picture. Even though they both form a line, you can kind of see that this first picture with the same-day forecast versus the 3-day forecast, and the same-day forecast, the points are a lot closer to the line, whereas in the other graph, they're a little bit further away. So this would be considered to be a strong positive correlation. Whereas there definitely is a correlation, but we wouldn't really call it strong. We might call it moderate positive correlation. Now, just to clarify, if you take further math courses and you go to take statistics, which is where they study this more in detail, there is a definitive formula that does indicate whether something is strong or weak or moderate. We're just kind of looking at the graph and sort of generally describing what we see in the graph. Okay. Now, just because two things are correlated doesn't necessarily mean that there is a definite cause and effect type relationship. So there might be some other possible explanations out there. So I'll kind of go through some big ones. So for one, it could just be a coincidence. Could just be nothing in common whatsoever. Just a bunch of random things get thrown together, and sometimes we see patterns where we might necessarily shouldn't see patterns. Secondly, both variables might be directly influenced by some common underlying cause. And the third possible explanation is that one variable may be the cause of the other. In other words, it might be what we think it is, that one is actually causing the other. The only way that we can truly do that is if we conduct what's called a clearly defined experiment, where we eliminate a lot of other parameters and just measure one specific thing and see if it makes a difference.